Hey, so we're going to talk about symmetry about the origin in this video, and symmetry about the origin is essentially a kind of a rotational symmetry. So a graph that has symmetry about the origin would be something like the graph of f of x equals x cubed. That looks like this, where it's not symmetric with respect to either the y-axis or the x-axis. But if we rotated by 180 degrees, so that's a half circle rotation, then the picture looks exactly the same. And for that, we have a similar test where if x and y and negative x and negative y are both on the graph, then we have symmetry about the origin. And so we can check this with a circle. So we want to show that the circle x squared plus y squared equals 25 has symmetry about the origin. And that's just as simple as checking that negative x squared plus negative y squared equals x squared plus y squared. And if x and y are a point on the circle, then negative x and negative y will be by this computation. So therefore, the circle has symmetry about the origin. Which makes sense because if we draw the circle, it looks something like this. That's at 5. Clearly, if we rotate this 180 degrees, it'll look the same. And we're going to show how symmetry can help us graph by looking at the graph of y equals 1 over x. So our textbook tells us that one of the first steps we should do in graphing is to check for symmetry. So we do check for symmetry. So we say that xy is on the graph. Negative x comma y. No, since negative y equals 1 over negative x. So therefore, plugging in negative x would give us negative y and not actually y. X comma negative y. No, same reason. But negative x, negative y is, since 1 over negative x equals negative y. Check, so we have symmetry about the origin, which we'll abbreviate to the SATO. And this is a really nice property to have in the graph because it tells us, and we'll see how it's useful, that if we know the right-hand side of the graph, then we know the left-hand side. So we'll figure out the right-hand side. And so maybe we want to graph the values. X equals 1/5, 1/3, 1, 3, and 5. And that will tell us that y equals 5, 3, 1, 1/3, and 1/5. And everyone should pause the video and verify that these corresponding values are correct. And so we draw a little graph. And we start to put in our values. So we have 5 at 1/5, 3 at 1/3, 1, And so we see it kind of looks something like this. And because we know it also has symmetry about the origin, that tells us that if we rotate it 180 degrees, it has to look the same. So we know that the left-hand side has to look like this shape. Right, and we'll do more with this graph later. It'll be a standard graph that we see throughout the course. But for now, we'll just leave it at this. All right, hope you had fun learning about symmetry.